So in this tutorial, and hopefully this tutorial will be a bit more brief than the previous tutorial, I'm going to go over how to address some of the issues that we discovered when setting up the character in the previous tutorial. Namely that while the low back, mid back, and head controls work fine in the Y and the Z axes, they rotate the joints in the spine backwards in the X. Same for the mid back control, and then same for the head as well. So that's the first order of business. I'm going to show you how to use utilities, which I like to describe as real-time calculators, because oftentimes in rigging and in other facets of 3D animation and game art projects, you often have the need to flip numbers from positive to negative, increase the numbers that you're getting by multiplying them by other numbers, decreasing numbers by multiplying them by negative numbers, so that things work more subtly or less subtly or in the opposite way, as we're going to set up here for these rotate X attributes. So we'll use utilities to fix that issue, and we'll also use them to soften some of the ways that these curves affect the spine. So the rotate Y, for example, is a bit severe. So a very subtle amount of rotation really twists the back pretty severely. So I'm going to use those utilities to soften those rotations a bit. I'm also going to use them to add another functionality. In the previous tutorial, I told you to lock the translates for the two back control curves, but I'm going to show you how to use those utilities to set them up so that the translate X and translate Z for both of these control curves will rotate only the first joint at their respective levels and not the other joints. So that when I move the low back control curve, I'll be rotating just the spine joint in the Y and the Z axes. And when I move the mid-back control, I'll be rotating just the spine 3 joint in the Y and Z axes. It's very common for an animator to come back to a rigger and say, when I work with this particular control, it affects the character too severely, and I want to be able to move or rotate this control without it rotating some part of the skeleton this severely. Or they might come back and say, when I move or rotate this control, it doesn't affect this part of the character severely enough. It's common for a rigger to use utilities to multiply or divide or add or subtract numbers from those values so that the controls affect the rig more subtly or less subtly to the animator's liking. So I'm not going to go over everything that we covered in the previous tutorial. I'm just going to go over those 3 objectives: fixing the backwards rotation X controls for the low back, mid back, and head controls, making the rotate Y a bit more subtle when twisting the spine with these curves, and adding the functionality that moving the low back and mid back controls in the X and Z axes will rotate just the first joint at each spine level. Okay, so this file represents everything that we went over in the previous tutorial, except for the connections between the low back control and the spine joints, the mid-back control and the spine joints, and the head control and the head joint. But in the previous tutorial, I had you lock and hide the translate attributes for the low back control and mid-back control. So I'm going to show you how to unlock and unhide attributes should you need to do that. We get to that from our Windows, General Editor, Channel Control. And there are 2 tabs here, Keyable and Locked, and 2 columns in each one. So in the Keyable, these are the keyable attributes. So right now the only attributes that are keyable for the low back control are the 3 rotate attributes. And then these are the attributes that are locked. So in the Keyable tab, I'm just going to find the translates, and I can do these both at the same time by selecting them both. Just find the translates, select them all, and then move them over to the keyable column. And that way, they now show up. And then to unlock them, I can also do that at the same time by selecting them both and just dragging over the attributes, right-clicking, and choosing Unlock Selected. So as I go through the use of these utilities, I'm going to try to explain to you in layman's terms what they're doing for us as we set them up, because it can be a little bit confusing. But utilities will have an input and output. And what we're going to do is we're going to connect the low back, mid back, and head control curves to inputs on multiply, divide, and plus minus average utilities, and then connect their outputs after those values are multiplied or added to other values and output them to the spine joints. So we're basically creating these sort of conduits that are real-time calculators that will allow us to multiply or add and subtract values before they're output to those spine joints or the head joint. And I'm going to set up one multiply divide and one plus minus average utility for the translate X and rotate Z of the low back control, for the translate Z and rotate X of the low back control, for the translate X and rotate Z of the mid back control, the translate Z and rotate X of the mid back control, and then one for the overall twist of the spine, and then one for the head. So the way we get to the utilities is in the Hypershade, which is under our rendering editors. And that's because utilities are most commonly used in shaders. So I'll go to my Windows, Rendering Editors, and open up my Hypershade. And down here in my Create tab, I have a category called Utilities. I'm just going to drag this so you can read the whole names. So I'm looking for the multiply divide, and they're alphabetical. So I'm going to create one multiply divide and one plus minus average. And then I can find those on my utility tab up here. I can find all of the utilities that I create. So the first one I'm going to call low back control translate X multiply divide. And I'll just copy this name so I don't have to write it all over again. And then I'll name this low back control translate X plus minus average. So what I can do is I can connect attributes to the inputs here. And what I'm going to do is connect the translate and rotate values of those curves to the first input, and then have them be multiplied, because the operation by default is set to multiply. I could also divide or use exponents, but by default they're set to multiply, and I'm going to be using all of these to multiply these numbers by other numbers, and then connect the output of these calculations to the spine joints or the head joint. So the first thing I'm going to do is connect the low back control, and I'll use the connection editor again. So I'll load that on my left, make sure it says from to to. And I'm going to use the multiply divide that I just created, add that on the right, and I'm going to connect the low back control translate X, so I'll find my translate X, to the input 1X. So in our multiply divide, this will be this value here. So it's X, Y, and Z, and it's important to note that the X, Y, and Z are simply the names of these fields. So this column is X, this column is Y, this column is Z. So the input of that translate X for that low back control will be input here. I'll multiply it by a number. I'm actually going to put -10 in here because I want it to be a nice subtle control. And then I'll connect the output of that multiplication to the spine joints. So this would be the input 1X, this would be input 2X, 1Y, 2Y, 1Z, 2Z. But they have no connection between the X, Y, and Z translates or rotates. They're just fields. They happen to be named X, Y, and Z. They could be named A, B, and C, or 1, 2, and 3. So try not to confuse the X, Y, and Z of these utilities with the X, Y, and Z translates or rotates of the various elements in your rig. So I'm going to connect the translate X to the input 1X. So this will be connecting the translate X of the low back control curve to the input 1X of that multiply divide utility. And then I'm going to set the input 2Y to -10. So what that will do is whatever the value is when I move that low back control curve in the X translation will be input into that first field, and it will multiply that value by -10. And then I'm going to connect the output of this to the spine joints. So this time I'm going to load the multiply divide in the output side, the left side, and I'll load the plus minus average. And by default, this is set to sum. I could subtract or average numbers as well, but by default it's set to sum, so I'm adding. And I'll load that into the right here. And I'm going to connect the output x. So the output of that multiplication of the translate of the low back control translate x times -10 to the first input here on the plus minus average utility. And I need to use these plus minus average utilities because I'm setting up the translate x and translate z to rotate just the first spine joint at each level. So I need to be able to add that movement to the rotation in that same direction, because if the animator moves the low back control or mid back control curve and rotates them, I need those two numbers to be added together so that the animator can both move those control curves to rotate the first spine joint at each level and rotate all three spine joints when they rotate those curves in the same direction. And that's why I use these plus minus average, because I need to be able to make sure that the animator can both move and rotate these control curves, and that those two values will be added if the animator moves and rotates those curves to keyframe any single pose. Because if the animator moves the low back control curve in the x-axis, that's going to rotate the first spine joint, which is named spine, in the z-axis. And if the animator also rotates that low back control curve in the z-axis, that's also going to rotate that first spine joint in its z-axis. So I need to be able to add those two numbers if the animator decides to both move and rotate that low back control curve in the same direction for any one pose. So what I've done is I've now connected the output of that low back control translate x times -10 to the first input of this plus minus average utility, which is set to add these values together. And then what I'm going to do is connect the low back control rotate z, because that's in the same direction, right? So translate x is side to side and rotate z is side to side. I'm going to connect that to the other input of that plus minus node. Now this is a little bit of a bug, not so much a bug, but a limitation. The other input for that plus minus average utility doesn't show up here in my connection editor. So in order to connect the low back control rotate z to the next input, I need to use a little bit of a workaround. And I'm going to use what we call sketching a MEL script to do that. So I'll first connect the rotate z to the input 1 that I connected the output of that multiply divide to. But I'm going to immediately undo that with z. So I just connected the rotate z of that low back control curve to the same input, which I don't want to do because I want to add it to the first number, and then I immediately click Z for undo. If I open up my script editor now, and I'll make it a little bigger so you can see that up here I connected the low back control multiply divide output x to low back control translate x plus minus average input 1D 0. So that's the first input field. And then down here I just did the same thing. I connected the low back control rotate z to the same input, that input 1D0. I don't want that. I want to connect it to the input 1D1. So that's why I immediately undid it. But what I can do is I can copy this, or just highlight it and middle mouse drag it here, and change the number at the back to 1, and then execute that command. So now what I've done is I've connected the low back control rotate z to the second input, the input 1D1 of that plus minus average utility. I know that's a little confusing, but I'm doing the same thing that I did with the connection editor. It's just that for whatever reason, this bug has been around since I've been working with Maya, that second input doesn't show up in the connection editor. So I've had to sort of force it with this MEL script. And we'll do this a few times, so I think you'll get it as you see me do this over and over again. But now what I've done is I've connected the first input for the plus minus average, which again is going to be adding those numbers together, was the output of this multiplication, right? The translate x of the low back control curve times -10. I connected that to the first input field of the plus minus average, and then I connected the rotate z of that low back control curve to the second input of that plus minus average. So now I'm going to connect the output of the multiply divide to the spine joints. So I'll load that here on my left. I'll select my first spine joint, which is just called spine, load it on the right, and I'm going to connect the output X to the rotate Z. So again, I like to line them up so I don't accidentally connect the wrong thing. So I'm going to connect the output X of that multiply divide to the rotate Z of that first spine joint. And then because the Z rotation worked correctly, right, they worked in the correct order, so I don't need to fix that. I'm just going to connect the low back control rotate Z to the next two spine joints of this level, spine 1 and spine 2. So I'll do spine 1 first. Connect the rotate Z to the rotate Z. And then do the same thing for the spine 2. Rotate Z of the low back control curve rotate Z to the spine 2 rotate Z. So now when I move this low back control in the X, you're going to see it's going to rotate just the first spine joint in that Z axis, but not the next two, right? You can see there's zeros in spine 1 and spine 2. So when I move the low back control in the X, I'm just rotating that very first spine joint. And that allows me to bend the back as a whole without curling it. And then when I rotate the Z, it's going to curl all three of those joints. So now I have an extra level of control here. I can move the spine and bend the back as a whole at the low back position. And I can rotate it and curl it in that same axis. So now I'm going to go about setting up the same controls for the other direction, the translate Z and the rotate X. So I'm going to create two brand new multiply divide and plus minus average utilities. So one more multiply divide and one more plus minus average. And I'm going to go back here and copy this, but this time it's going to be translate Z, just so I don't have to write this over again. So this one will be called low back control translate Z multiply divide. Copy that again. And this one will be called low back control translate Z plus minus average. And I'm going to set up the connections in the same manner. So the first thing I'll do is I'll select the low back curve, open up my connection editor, load that on the left, select that newest low back control translate Z multiply divide and load it on the right. And I'll connect the translate Z this time to the input 1X. Then again, I'll set the input 2X to -10. And then I'm going to connect the low back control translate Z multiply divide output X to the first input of this new plus minus average, the low back control translate Z plus minus average. So I've now connected the output of that multiplication to the first input of the plus minus average. And then I'm going to have to use that workaround again. So I'll load the low back control on the left now and connect the rotate X to the same input. Immediately undo that with Control Z or Z. Open up my script editor. Drag that down. Replace the 0 with 1 so that I'm connecting this low back control rotate X to the second input of that plus minus average and execute that command. And now I'm going to connect the output of the multiply divide, the output X, to the spine rotate Y, because rotate Y is in this direction, right? For this control, Z is in this direction, and it's the rotate Y of the spine that's in that direction. So I'm going to connect the output X to the rotate Y. Just going to line them up. And then I'll connect the rotate X of the curve to the input 1Y. So this field of the low back control translate Z multiply divide. Because I need a different multiplication now. I don't want to multiply this number by -10. I want to multiply it by only -1. So I'm going to connect the low back control rotate X to the input 1Y. And then I'll set this number not to -10, but to -1. And now I'm going to connect that output Y to the second two spine joints. Spine 1. Again, it's rotate Y in this direction. And the same thing for the next spine joint, spine 2. So now I've set up this low back control so that when I move it in the X, I'm rotating just that first spine joint in that Z axis, but not the next two, right? There's no rotation Z in the spine 1 or spine 2. When I rotate in Z, it curls those spine joints. And now I have the same thing for the Z. So when I move the Z, it rotates just the first spine joint in the Y direction this time. And then when I rotate in the X, it curls the joints. And you'll see now that it curls them in the correct direction. So when I rotate this curve forward, the spine curls in the right direction. And that's because I'm multiplying that number by -1. So that's giving me the opposite. And that's the problem I identified that we needed to fix in the first tutorial. So now I'm going to go about the same exact process that I did for the low back control for the mid back control. So I'll try to go through this a little bit faster since I won't have to explain every step now. But again, the first thing I'm going to do is create one multiply divide, one plus minus average. This one I'm going to call, again, I'll just copy these words so I don't have to write everything all over again. And this one's going to be mid back control translate X. And I'll connect the mid back control translate X to the first input of this new multiply divide. And then I'll change this to -10. And then I'm going to connect the multiply divide to the plus minus average. So it'll be the output X to the first input. And then mid back control rotate Z to that same input, immediately undo it with Z, go to my script editor, find the code, middle mouse drag it down here, change the 0 to 1, and execute that command. So now I'll connect the mid back control output X to the first spine joint at the mid level, spine 3. And it'll be the rotate Z this time. And then I'll connect the mid-back curve, rotate Z, to the next two spine joints. Spine 4, rotate Z, and spine 5, rotate Z. So again, create one new multiply divide, one new plus minus average. I'm just going to copy these names. So this time will be translate Z for the mid back. Select the multiply divide, load it on the right. So now it's going to be the mid back control translate Z to the input 1X. Change this to -10. connect the output of the multiply divide to the input of the plus minus. So output X to 1D, and then load my mid-back control. And this time it's going to be the rotate X to the other input. So I'll connect it to the first input, hit Z to undo that, go to my script editor, find the code, and it's always going to be near the bottom. Drag it down, change the 0 to 1, execute the command. And now I'll use the output to that first spine joint at the mid-level, the spine 3. So the output X to the spine 3 rotate Y this time. And now I'm going to connect the mid-back control rotate X to the second, the Y column, the first field in the Y column. So the rotate X to the input 1Y. I'll change the input 2Y to -1 so that I'm flipping that number around. So this time I'll load this output for the Y. So now I'm going to connect the output Y to the second 2 spine joints at the mid-level, the spine 4. And it'll be the output Y to the rotate Y. Same thing for the spine 5. So now I have the same setup with the mid-back. When I move in the X, it rotates just that first spine joint at the mid-level, that's spine 3. When I rotate in the Z, it curls all 3 of the spine joints. When I move in the Z, it bends just that first spine joint, spine 3, at the mid-level. And when I rotate in the X, it now curls and in the correct direction because I'm multiplying those values by -1. So now I'm going to set up one for the back twist. And this time I only need a multiply divide. And I'm setting this up solely because I want this rotate Y to be a little bit more subtle. So I'm going to multiply it by a fraction, a number under 1, so that the rotation isn't so severe. And I'm going to twist the spine only from one level. So I'll eventually lock the rotate Y for the mid-back and twist the spine as a whole just from that low back control curve. So I'll create a new multiply divide. And this one I'm going to call back twist multiply divide. Again, these numbers are just personal preference. You don't necessarily have to use the same ones, but I would suggest you do if you try to follow this tutorial, because it's probably going to be a little bit confusing the first time you go through it. So I'll connect the low back control rotate Y to the first input, the input 1X of that back twist multiply divide. And I'll connect the low back control rotate Y to both the input 1X and the input 1Y, because I want to be able to rotate the low back and mid back at slightly different levels of severity. So then I'll set the input 1, 2, and I just chose these numbers based on how they look on my character. You might use higher values or lower values depending on how the curve twists your spine, depending on how your character is designed. But I just chose these numbers because I thought it looked right, and if I was an animator, it's about how I'd want it to affect the spine. And now I'll use the connection editor to connect the output of this multiply divide to the various spine joints. So I'm going to connect the output X to the spine 1 and spine 2 rotate X, because rotate X for the spine joints is the twisting direction, and then the output Y to the spine 3, spine 4, and spine 5 rotate X. So I'll use the spine first, find the rotate. So output X to rotate X for spine 1, output X to rotate X, spine 2, output X to rotate X, and then spine 3, I'll connect the output Y to the rotate X, and then the same thing for spine 4, output Y to rotate X, and spine 5, output Y to rotate X. So now when I twist this, you'll see that it twists the back a bit more subtly. Because you can remember, when I got to about this level, the spine would have already twisted around well beyond what the human spine can do. So multiplying by those fractional values, that 0.25 and 0.35, I'm able to control this a little bit more subtly. And this is about how I'd want it to work as an animator. So you can test this out for yourself and figure out which values give you the effect that you are looking for. So now I'm going to set up the fix for the rotate X of the head control, so that when I rotate this curve in the X, the head rotates forward and not back. So again, I only need a multiply divide for this. So I'll create a new multiply divide, and I'll name this one head rotate X multiply divide, and I'll connect the head control curve rotate X to the first input, the input 1X here. And then I'll change this value to -1 because I need to flip it. And then I'll connect the output of this to the head joint rotate Y, right? Because that's the direction that I want here. And then I'll just connect the curve again in the other two axes directly to that head joint. So it'll be rotate Y to X and rotate Z to Z. So now when I rotate this head control, it works correctly in all three axes now. So now when I rotate the curve forward, it rotates the head forward. So that's how I've used utilities to flip the values around so that the curves rotate the spine and the head joints in the correct direction, to make the rotations of the twisting a little bit more subtle, a little bit more natural, and to add the functionality of connecting the translate X and Z for both the low back and mid back control curves to the rotations of just the first spine joint at each level, so that moving the curves in the X and the Z bends the spine as a whole at each section. So then I would go through and I would lock and hide the attributes that I don't want the animator to get to, just like I did at the end of the previous tutorial, but I won't go through that again. So this is a very common way for riggers to use utilities. They can be used for myriad applications in rigging, particularly in shader creation, texturing, but even modeling and non-character rigging. So setting up pistons or mechanical objects or the steering wheel of a car, the axles of a car. You can connect the steering wheel rotations to the rotations of the wheels on a car. And often in those kinds of situations, you'll use utilities to connect things in ways where connecting one attribute to another directly won't give you the result that you're looking for. So again, this is just an optional way for you to go for the manual rigging assignments. You certainly don't have to go through this process. I just wanted to create this tutorial for any students in the course that might be interested in pursuing rigging as a potential career. It is one of the careers that you really don't have to have any traditional art skills, drawing, sculpting, painting. You do need to have a head for logic. You need to be able to learn how to code, at least at a very rough, basic level. I'm certainly not an expert with Mel coding, but I can get through it with sketching the code, what I did here to fix that input bug. So rigging can be a great way to get into the field if you're not terribly strong with drawing, painting, and sculpting. So consider giving this tutorial a shot. Even if you don't end up turning it in, it's a good way to start learning about some of the more advanced ways in which Maya works. And even if you aren't able to follow the tutorial successfully in your first try, one of the best ways to learn 3D software is trial and error, and making mistakes is one of the most beneficial things that you can do, because you'll learn about what not to do next time, and you'll often learn something in the process of making that mistake. So don't ever be afraid to get in there and try something out, even if you're not completely confident that you know what you're doing yet, because you really can't break anything. Save incrementally, save often, but don't worry about breaking anything, because you really can't.